Hello everybody, this is Dr. Pennington again, and in this video I want to spend a few minutes telling you about how to name ionic and molecular compounds. This is a really important skill because you're going to be using it all the way through first semester and all the way through second semester, and then in organic, and you'll be using it a whole lot of time, and then analytical and all that stuff. So whenever you talk about naming compounds, the first thing you have to understand is my compound ionic, or is it molecular or covalent? In other words, are there ions present or not? And what's the simple way to remember if you have an ionic compound or not? It really is very simple, and that is, do you have a metal and a non-metal present? Well, if you have a metal and a non-metal, then that means you have something ionic. For example, LiCl, ionic. NaBr, ionic. Is this ionic? Well, no, it's not, because nitrogen and oxygen, neither of those is a metal. Is this ionic? No. Again, there is no metal present. And now it turns out the rules for naming each of these are different. There's one convention for naming ionic compounds, another convention for naming molecular or covalent compounds. Alright, so let's just go through a few examples. Alright, now before I move off this slide, there's something I just want to point your attention to. I've just pulled tables 3.2 through 3.5 from your textbook, and we're going to be coming back to these several times during this video. Whenever we're talking about naming, we want to talk about the cation and the anion. We have simple cases of cations where the group number dictates the charge. Apart from transition metals, where that is not the case. The transition metals can all form potentially different sets of charges, and we're going to go through and see, for example, sometimes we'll form chromium 2, sometimes chromium 3. As you would imagine, the names are different. So for transition metals, when you're writing out the name, you put the charge of the metal after its name in Roman numerals, in brackets. You'll see that most of these transition metals can form two different charges, okay? And these are the ones that we're going to focus on. Some common anions. These ones are pretty simple. We have the halogens here that all form one bond. They have a charge of 1 minus. You can figure out the charges just by looking at the group. Fluoride's in group 7, or fluorine's in group 7. It wants to gain 1 electron, so therefore minus. Oxygen, all these guys, oxygen and sulfur are in group 6. They want to gain 2 electrons. Nitrogen and phosphorus are in group 5. They want to gain 3. Notice the names of the elements themselves, and then the names of the anions. Notice that the anions, these simple anions, always end in the same 3 letters, IDE, based on this base name. Alright, fluorine, the root for that is fluor, chlorine, chlor, and so on. From those base names you get the names of the anions. The thing that's going to give you guys most trouble are the polyatomic ions here. For example, sodium nitrate. Some of you will try and take the nitrogen and oxygen and split them up and somehow name it that way, and that's not going to work because nitrate has its own formula. So the big question is, how are you going to figure these out? Well, this comes down to memorization. This is one of the few things we actually want you to memorize and get these down. Because, for example, for chloride, chlorate, and perchlorate, it's not the easiest thing to rationalize why the names are the way they are. And hypochlorite, that's tough to rationalize as well. Some of the names you can, but a lot of them you can't. So table 3.5, through whatever method, whether it's writing out your own flashcards, using the electronic flashcards that I'll put on Blackboard, or whatever, get these memorized. because you can't guarantee that your professor is going to give you these on a quiz or an exam. If you're in my class, then you wouldn't have this, so you'd have to know them. Anyway, let's go through some examples, okay? We can do two things here. We can go from formulas to names, or from names to formulas. So let's go from formulas to names. And I'm just going to write some out here before we get going. So we have this, and we have this, and we have this, and we have this, and I'll just do two more. We'll do this, and let's also do this. Well, actually, no. Let's not do that. Let's do. Should be a 3 there. Sorry, that's a really messed up 3. Let's do this. All right. So the first thing we have to ask ourselves for each of these, ionic or molecular. Well, hopefully you guys can follow along with what I'm saying here. We're just looking to see if we have metal and a non-metal. Yeah. So molecular, no metals, molecular, no metals, all these other have metals, therefore they're ionic. So let's do naming the ionic ones. These are a little bit more simple. All you do, you put the name of the cation first and the name of the anion next. So when we go back to our table, the name of the sodium ion is actually the name is the same as the atom, so that's sodium. Bromine becomes bromide, so therefore the name of this becomes sodium bromide. Alright, let's come back to this one and go down to this one. K, of course, is potassium. But then what's that? Manganese oxide or something. Let's anytime you have your anion that consists of more than one different atom, make sure you check the polyatomic ion table and see if it's there. So we're looking for MnO4. Oh, there we go, MnO4 minus. Permanganate. Potassium permanganate. Kind of a long name. Notice that the table said the MnO4 was had a charge of -1. The potassium has a charge of +1, so those charges balance out. You've always got to make sure that your charges balance out. Br minus and A plus. Now let's go down to here. Li is of course lithium, nitron, N, nitrogen of course. And just N by itself, there it is, nitride. Lithium nitride. Now notice one thing that I haven't done here. There are 3 lithiums, but I didn't indicate 3 anywhere. There are going to be 2 fluorines here, but I'm not going to indicate 2. And that's because for ionic compounds, there are never any numbers of ions present. So you don't use any prefixes or di or tri or anything like that. Even if you had something like CaCl2, calcium chloride. It's not calcium dichloride, all right? You don't use any numbers or prefixes when you're talking about ionic compounds. When you talk about molecular compounds, you do. And that's the main difference. But let's finish off this last ionic compound here. Cu. What is Cu? Well, Cu is copper. And when we go over here, copper doesn't come in this list, and that's not a surprise because copper is a transition metal. So copper can exist as copper 1 or copper 2. So in order for us to name this, we have to know, well, what do we have? Well, I have 2 fluorines, or 2 fluorides, and each fluoride has a charge of -1. So therefore my total charge here is -1 times 2, -2. So therefore the total charge on my copper must be +2. So therefore I have copper fluoride, but because copper is a transition metal and we had to indicate the fact that it has a charge of 2, we put that 2 there. copper 2 fluoride. Now let's do the two molecular ones. Remember we said you don't use prefixes to indicate numbers of atoms in ionic compounds, but you do in molecular compounds. B is boron. And fluorine, of course, is fluoride. Alright, so when we're naming molecular compounds, we name the first element just as we would name it normally. For the second element, we name it as if we were naming an anion. So this F becomes fluoride. But the main difference is, here we do indicate a prefix for the number of atoms that we have. And those prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, so on. So therefore, the whole name of this would be boron trifluoride. And then when we go up to here, you may have a question about this, and we'll come back to that in a minute. What's the prefix for 4? Well, the prefix for 4 is tetra. Tetra phosphorus. Phosphorus. You remember we said you always name the first element just as you would normally. Oxide is going to be here for oxygen, and the prefix for 10 is deca. And in the English language, you'll find very, very few letters where two vowels are together like this. Mainly because we have a hard time pronouncing those. You'll find them in, say, Danish and Swedish, but not in English very often. So what we usually do is, if the prefix is deca, we'll lop off that A and just leave the O. But some people will say tetraphosphorus decoxide, some people will say deca oxide. It doesn't matter which one you say. So remember, you use prefixes for molecular compounds and you don't for ionic. So one question you might have is, why is there no prefix here? Why isn't it monoboron trifluoride? Well, this is the one little caveat here. If you have one atom of your first element, there is no prefix. If it's anything else, there is a prefix. So if this was 2, it would be di, 3 would be tri. And that's just the way it is. So if you have one atom of your first element, then you don't include the prefix. And that's just the way it is. Now what if we were to go the other way, names to formulas? Alright. So I'm going to put in some names here. And actually that's a little big. Let's do this. And first we'll do beryllium iodide. Alright. And let's do another one. Let's do, what should we do? Let's do nitrogen dioxide. Oops, if I can spell it right. Nitrogen dioxide. Let's do another one. I want to illustrate the fact that even with two of the same element, you can have a bunch of different names. Dinitrogen monoxide. Then let's do dinitrogen tetroxide. Then we'll do, let's see, what should we do here? Let's do sodium dichromate. We'll do, let's do tin for oxide. And then let's just do one more. Sodium, oh no, not that. Copper 2 sulfate. Alright, okay, so let's just go through these. We're going to go through these in exactly the same way we did before. First, ionic or molecular. Okay, so is there a metal? Well, beryllium's a metal. Nitrogen and oxygen are not. They're still not. And they're still not. Well, sodium here is a metal. Tin is a metal. And copper is a metal. Alright. So again, let's do the ionic ones first. Beryllium. Now beryllium is in group 2. So therefore it forms a charge of 2+. Iodide is in group 7, forms a charge of 1-. So if you have beryllium 2+ and I-, how many iodides do you need for every one beryllium? Well, of course you need 2, and the formula for beryllium iodide is BeI2. Let's go down to, let's do sodium dichromate. Now we know sodium is Na. We also know sodium has a charge of +1. When we see the name of an ion that doesn't end in IDE, then that should tell us, that anion is not just one single atom. Alright? Iodine, oxygen, 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 oxygen. Dichromate and sulfate both suggest polyatomic ions because of what they end in. But let's go see what they are. Remember, one was dichromate, and there it is, dichromate, Cr2O7 2-. So it contains chromium, oxygen, and with a charge of 2-. Cr2O7 2-. So therefore, how many sodiums do we need? Well, of course, we need 2 for every 1 chromium. That's sodium dichromate. Tin 4 oxide. Now the formula for tin is Sn. Tin is a transition metal, so you would have to be told the charge of tin. Is there anything here that tells you what the charge of tin is? Well, of course, yes, there is this. 4. Therefore, the charge on this tin is 4+. The charge on oxygen, well, oxygen is in group 6, wants to gain 2 electrons, so therefore it forms a charge of 2-. So therefore O2-. Therefore, how many oxygens do we need for every 1 tin? Of course, that is 2. Let's do the same thing here. Copper 2, so copper 2+. Sulfate, now the only thing we know about sulfate is that it's probably got sulfur in it. Sulfate. When we go down here, we'll notice there are 3 ions that contain sulfur. Actually, there's more. We are concerned about sulfate. This one, and that formula is SO4 2-. It's really important not to confuse sulfite and sulfate. They're very similar. SO3 2-, SO4 2-. So make sure you can distinguish that. SO4 2-. So therefore, the charge, the formula for this would be CuSO4 with 1 each because the charge is balanced. All right, let's go up to the molecular compounds. You remember we said that if for the first element there is no prefix, then that means there's just one of those atoms. Di, of course, means 2, so therefore 2 oxygens. Dinitrogen monoxide, so here the prefix for the nitrogen is 2. What's the prefix for the oxygen? Well, it's mono, meaning 1. And then down here, dinitrogen, that's just like it was here. In this case, it's tetroxide, meaning 4 oxygens, and that's it. So that is how we name ionic and molecular compounds. First off, figure out is it ionic or molecular, and then break it down to its ions if it's ionic, and just follow the name if it's molecular. Alright, that's it. Thank you.